Neurologically speaking, why do we choke in sports and in life? This question was at the foundation of research conducted in Pittsburgh, Pennsylvania, that tapped into the brains of monkeys to examine how pressure affects their ability to complete certain tasks. Steven Chase and Aaron Batista led the research team. Steven is a biomedical engineering professor at Carnegie Mellon University, and Aaron is a bioengineering professor at the University of Pittsburgh. And they're both nice enough to join me to discuss this research, its overall arching goal, and more. Guys, thank you so much. Steven, thank you for the time today. How you doing?
Excellent, thank you.
Aaron, how about you? Everything going well on your end?
Very good, Trey. How about with you?
I am doing great, thank you. And as somebody who loves to take a look at research and just see what the work of others can tell us about ourselves and the world around us, I was really intrigued to learn about something that you guys just took part in that was reported for the first time in the Score about a month ago. And it has to do with researching monkeys to understand why we tend to fold under pressure. So, Steven, we'll start with you here. Where along this process did you really start to get involved in things as you guys overseeing the research here?
Yeah, this study really got underway almost a decade ago. I think it was 2014. And Aaron and I have been studying motor control for a couple of decades, and we've always been interested in the role that rewards play in motivating actions and in learning. And in one day, I don't even know what started it, but one day we started talking about choking under pressure, about how athletes, in some of the biggest moments, statistically speaking, perform less good than they can. And we started wondering, is this a human specific phenomenon? Is it because we overthink it? Our big brains are causing us to trip at those critical moments? Or is this something that really any animal would do? And that's how the study got started.
So how exactly did this team go about conducting the research, Aaron? What did they do to test whether or why these monkeys fold under pressure too?
Yeah, it turns out it didn't take all that much to get this result. There was a lot of foundation that had to be laid, and the idea had to cross our minds. But we have animals performing challenging dexterous motor behaviors in the laboratory all the time already, and we decided to just see what would happen if we changed their incentive by offering them bigger or smaller rewards, all the way up to a jackpot for occasional success at a difficult task. And it doesn't take a stadium full of 10,000 adoring fans calling out your name to lead you to choke under pressure. It can happen in routine behaviors that are encountered in ordinary lives, and ordinary people do it, and turns out even monkeys in a laboratory will choke under pressure.
What was the jackpot, Aaron?
Just a massive drop of something the animal liked, whether it's Tang or Kool-Aid, or we find out what the animal is into. We tell them they'll get a lot of it, have a little color cue that lets them know the payoff is going to be huge for this one, and that's enough to put the pressure on them and lead them to choke.
Steven, did you guys also look at whether simulating some sort of crowd noise, so I guess an oral distraction, had any impact on pressure too?
That's a fantastic question, and we haven't done that. We haven't looked at the role of distraction yet. There's so many variants of this task that we want to do. It's interesting. There's actually been a debate in the psychophysics literature with humans. What actually causes that pressure? Are rewards enough to motivate it, or do you need some kind of sense of loss or sense of performance to engage those performance anxiety feelings? For us, it was just rewards, and that was enough.
And so, Steven, we'll continue, I guess. So what were the findings here?
The findings were a remarkable robustness. Statistically speaking, as you increase rewards from very small to medium levels to large levels, monkeys get better at the task. Their success rates go up on this challenging task. And for us, we tried to titrate all the parameters. The average success rate was about 70%. And we saw at the smallest rewards, it was really about, 60%. And at the large rewards, it was really about 80%. So a large swing in success rate. And then on those rare 5% of trials when that jackpot was on offer, their success rates plummeted. And they plummeted substantially down to about 60% again. And so it was really a very remarkable effect. And it was consistent. It happened almost every day. It happened at the beginning of the day and it happened at the end of the day. We tried a couple of different variants of the task and it happened there. It's a remarkably consistent effect, even more consistent, I think, in the animals than it is in humans.
So, Aaron, did you guys have electrodes hooked to their monkey brains? I mean, how are we figuring out what's happening neurologically when
That's right.
primates are choking under pressure?
Yeah, to our great surprise, it turns out that the same areas that control the coordination of our muscles are also sensitive to the outcome of the action, including what the payoff is going to be. So that we found this interesting mixture between signals of anticipation and motivation and signals of sensory motor coordination. And like Steve is describing, when the payoff goes from small to medium, those signals tend to improve. But then when the payoff goes from medium to jackpot, the signals degrade in quality, which is really quite a remarkable thing. And if I can say a little bit more about it, the degradation is highly predictive of the animal's failure. So you can sit there and watch on trial by trial. Here's one where the animal's going to miss it because the neural activity is dysregulated because of that outsized potential reward.
Wow. So not as focused then?
I don't know, Steve, what's the right word for it? Would you call it focused or what?
It's hard to know. I don't think it's a distraction-based effect, like the word focus might imply. What seems to happen when they tend to move too slowly. They end up short of the target. It's almost as if they're overcautious. They're worried about missing out on the reward. And because they're worried about missing out on the reward, they miss out on the reward.
A little bit of a self-fulfilling prophecy. Yeah.
So is this the motor cortex, the region in the brain that you're talking about that has an effect here?
That's right.
That's right.
Huh.
Yep.
How surprising was that, Steven?
I want to say it's very surprising. We really didn't know how this was going to turn out. Motor cortex was a logical place to look because it's the last cortical area. It's responsible for sending a lot of axons down the spinal cord, giving you direct control over your muscles. So it's sort of the last stop in cortical processing of movements. But whether it was going to show these big reward effects, we really had no idea. So the fact that they were so clean and so consistent, that is what was really surprising. Was
it surprising to you, Aaron?
Yes, it was. We like to take bets at the start of an experiment, and it's 10 years ago now, and I forget where we aligned, but one of us was certain monkeys wouldn't choke, and the other was certain that they would. And then, once we knew that, we then took another round of bets to find out if it would show up in motor cortex or not. I will say, now that we've seen it in motor cortex, I would not be surprised if it's everywhere. Look, we're highly emotional creatures, and athletes are both have exquisite motor skill and also have the ability to keep their emotions under control so that it doesn't interfere with their performance. They can feel it more than we do, and they can self-regulate it better than we can. So I won't be surprised. We want to go look elsewhere in the brain, but it's not just motor tasks that we choke on. We can choke in public speaking, on the radio, you name it. So there may be lots of places where we can see an adverse interaction between neural control signals and kind of emotional valence signals, sometimes helping, and in these rare instances, really interacting in a negative way, an adverse way.
Steven, what types of monkeys were being utilized here?
These are rhesus macaques.
Okay.
And I'll just say that these are a species that has been wonderfully enabling for all kinds of research, not just neuroscience, but also COVID vaccine development, reproductive health. Lots of disease models have been developed and human diseases have been cured using the exact same species of rhesus monkeys that we have the privilege of working with in the lab.
Yeah, the rhesus is very valuable in this regard. I'm curious, though, as it pertains to the brain, is there a reason neurologically why the rhesus monkey would be better to study for something like this than like a bonobo or chimpanzee, considering that those are the two non-human species that we share the most with genetically?
When looking for a species to use, we want something that's going to mimic human motor control as closely as possible. The rhesus macaque is a really nice model for this. It's got a gyroencephalated brain, meaning it's got the same kinds of folds that humans have. They perform visually guided reaching, and they're relatively trainable, but not as valuable as, say, chimpanzees, not as hard to find in the wild. They're not an endangered species. And so we try and balance these things as good a model of human motor control as we can get, while being something that's not going to impact the ecosystem at all when we study it.
All right, shameless admission time now, guys. I'm very jealous of you both. I love the idea of getting to study the brain for a living and to get to conduct research like this. So kudos on your profession selection.
Well, we'd love to be on the radio, Trey.
Many years ago. The grass is always greener, right? So I want to ask each of you this: what ultimately made you want to pursue this career path? And Aaron, you can go first here.
Oh man, I was hoping to have a moment to think about it.
Steven, you're welcome to go first if you're ready.
I'm happy to go first. So a lot of our research is actually focused on clinical application. And the specific clinical case we tend to focus on is brain-computer interfaces. And these are devices that are developed for people who are paralyzed, quadriplegics, can't move, stuck in a wheelchair. And the idea is to implant electrodes in the brain to tap out motor control signals and use those signals to either reanimate the subject's own limb or to control a robotic arm to give them restored motor abilities and ability to interact with the external world. And a lot of our basic science research is to serve that purpose. And this specific study is really about how do emotions creep into motor control signals. And that's something we need to know. If we're going to decode a subject's motor intent, in order to control a robotic arm or something like that, we need to know how are these signals normally regulated by emotions, so that when emotions come in, as they're going to happen when a subject's using a device, that we can properly account for that signal and not have it cause the robot arm to do something bad. So really, a lot of my motivation is on the clinical application end, and this study is a really neat basic science study that is along those lines.
That's really cool to hear about. So is this something similar to the Neuralink technology? Because as I understand it, I know everybody gets freaked out because it's a brain implant and it's Elon Musk, but at its foundation, as he has talked about before, it's really about helping people who have suffered spinal cord injuries. I believe epilepsy has also been mentioned to gain some greater sense of normalcy in their lives in terms of that disability.
Yeah, it's exactly the case. So yeah, we've been doing the research, and Neuralink has come in and is now trying to commercialize the research, and they're doing a very good job at that.
Yeah, they have what they need to reach potentially many more people in the here and now than Steve and I will be able to reach. There are real opportunities for a partnership there. And one thing I would say to their overall effort, and I think they're very astute and well aware of this, is that if you really want to restore motor function to people, you must understand the whole milieu in which we behave. You've got to understand that it is not just a sensory motor control problem, It is also a problem of context, the emotional situation, what the goals of the actions are, what the long-term action of the individual is. And the more we know about how the brain represents movement in natural environments, the better the control algorithms and restoration are going to be.
Oh my God, that is crazy. So Aaron, what led you to want to be want to work this sort of job?
Yeah, what a great question. So I find great peace in the idea that the mind is created by the brain, that our minds are the action of our brains. And the reason why that's so powerful for me is because it helps us be more forgiving when we encounter failings of cognition or brain diseases that impact our sense of self, our ability to move, our emotional state. If we can be more tolerant of each other and more forgiving of ourselves because we understand our mind is just the action of our brain, I think that puts our society on better footing and leads toward potential treatments.
The mind is the actions of our brain. So there is a common frustration among philosophers to try and define what exactly the mind is. That might be the most beautiful definition I've ever heard for that concept in my life. Is that an
It's
Aaron?
not mine, but it's what drew me into the field.
It's not yours, but it's what drew you into the field. Do you remember where you read or heard that for the first time?
The my favorite place to find it is the writings of Francis Crick, the guy who just co-discovered the structure of DNA.
Yeah.
He, you know, he became a neuroscientist later in life, and he wrote a book called The Astonishing Hypothesis.
Hmm.
And the astonishing hypothesis is the idea that the mind is nothing other than the action of the brain.
Steven, anything you want to add here?
I think that sums things up very well. Uh, I think, actually, I wanted to add one more thing about our particular study. I
Sure.
think the most surprising thing to me that we found is how much more consistent this choking under pressure finding is in animals than it is in humans. And so to me, this idea that it's our big brains that cause us to trip and choke under pressure, it's actually our big brains that cause us not to choke under pressure.
Huh.
And I think, I suspect, can't prove this yet, but we're working on it. I suspect that athletes really should be choking under pressure way more than they do. And it's really just an astonishing fact that they don't. Every time they don't choke under pressure, that's what's amazing.
Last night, Domingo Herman pitched a perfect game for the Yankees,
Yeah.
right? And in the interview afterward, he said exactly what Steve is saying. I could feel the nerves and I kept it under control. And look what I did. I created a perfect one.
Yeah, it's crazy with him, especially because he has not been very good this year. But I think that's also one of the things that that shows the strange magic that is baseball, right?
Yeah. This is why we like the live event more than going to the scrimmages and the preseason practices. It's
Yeah.
when the emotions interact with the motor skill that it gets interesting.
And why seeing it in person is even better than seeing it on television too, because you are actually physically there.
Part of history.
Although slow-mo makes things pretty cool on the TV side, I guess. All right. Want to finish things off with the subject of pressure and asking each of you guys if you have both a moment where you folded under pressure and a moment where you excelled under pressure. So I'm going to give Aaron a chance to think about this one. Steve, is there a moment where you completely collapsed under pressure? And if so,
It's not a single moment, but I used to play racquetball with a graduate student friend of mine when I was in grad school. And nearly every game, I would get ahead. I would always start out strong. And then I'd get to match point and fold. And so he would come from behind and beat me almost every game. I am ridiculously subject to this problem.
have you figured out what it is? Why it happened?
Clearly, I don't have one of those athletes' big brains that allows me to overcome this problem that the rest of animal kind suffers from.
Gotta like take a couple breaths on game point or something, man. This can't keep happening. Aaron, how about you? What's a moment where you folded under pressure?
Yeah, too many to count.
Okay.
I spent a lot of time as an enthusiastic amateur dancer, a particular style called West Coast swing that happens to be popular in Austin.
West
And
Coast swing.
West Coast swing, yeah, it's a really wonderful dance. It's a little bit of a modernization of Lindy Hop. It's a joy to watch. There's great videos on YouTube, and nothing beats seeing it live, like any athletic performance. But
Is
you know,
this
I
like
had
what was showcased in the movie Swingers back in the 90s?
similar, very
Okay.
similar. Yep, exactly. That's a great reference. I love that movie. It's been a few years, but there's still a community out there that dances it, and they are intense and they take it very seriously. And most of it is social and fun, but every now and then there's a competition, and you can always tell who's able to keep their nerves under control when everybody's watching you, and when the stakes are high in that particular environment.
And so
It's
you
just a joy to see.
competed
Yep.
then.
I did, but I folded too often to get very far, and certainly have tons of friends and acquaintances who manage to keep their nerves under control. And what they create, spontaneous improvisation in the moment, it's a joy to behold and to realize it's all not choreographed. It's just artistic expression in the moment. It's astounding.
Oh, I didn't realize how abstract it actually is. It's like very
That's
like the
right.
next thing that strikes you is what you want to do is what you do.
That's right. And you're doing it with a partner, so you must communicate your intentions and be sensitive to theirs.
Oh, wow. Those subtle
Yeah.
nonverbal cues. That's crazy. Okay,
Yeah.
so Aaron, we're going to start with you with this final one then. What is a moment where you excelled under pressure?
Oh, goodness. Managed to get myself married to one of those dancers. So I must have said or done the right things at the right time.
That's a good answer. And Steven, how about you?
I was in a job interview giving a talk, actually, my job talk. And I was about halfway through, and I mentally lost track of where I was in the talk. I had no, I have, and I just, it's like looking at the slide going, I have no idea what I'm supposed to say next. But I was still speaking, and I blazed through the talk. It wasn't an issue whatsoever. Cognitively, I had no idea what I was doing, but I was on, and I just kept going.
What was the general subject
Autopilot.
of the talk?
Uh, Research. It was it was for the job I'm currently holding, actually. So I managed to land it.
Yeah, that's excelling under pressure right there. Well, guys, thank you so much for the conversation today. Really enjoyed it. And hopefully this isn't the last time. I'm going to keep track of the work that's coming from each of you. And best of luck with that ultimate goal, which is to help those with spinal cord injuries to recover in some way, shape, or form.
Thank you
Thank
very
you
much.
so much.
Thanks to Gentleman Jesus for the intro and outro music. Hear more of his work at gentlemanjesus.com. And thanks to you for hanging out. For more of the show and to connect on social media, visit booksonpod.com. We'll talk to you next time on Books on Pod.